This is 2017 mathematical method, written exam 1 suggested solution for Northern Hemisphere timetable. Right, so today I'm going to record my suggested solution to this 2017 Northern Hemisphere exam. And you know, in Northern Hemisphere, there will be another parallel timetable, which normally happens in the mid-year. So there are another bunch of students in Northern Hemisphere, like in China or somewhere else, doing BCE, but they're using different timetables. I think their paper should be, in terms of difficulties, comparable to our Southern Hemisphere timetable, which are also very useful to inform us how the exam paper will look like. Yes, they come from VCAA. So let's get started. Question 1, let y equals e to the power of 2x, cosine half x, find dy dx. Let's make a use of product rule. Let u equals e to x, v equals cosine x on 2, u dash equals 2e to x, v dash equals minus half sine of x. Okay? Now, dy dx will be u dash times v plus v dash times u, which is 2e to x times cosine half x minus e to x times half sine half x. Notice that this plus becomes minus because of the minus sign here, okay? And let me tidy it up. 2e to x cosine half x minus half e to x times sine half x. Okay? All right, good. Let's move on. Let f 0 to pi restricted, where f of x equals log e sine x. Evaluate f dash pi on 3. Okay, so if I notice the pattern of that function, it's a composite function in terms of log function, I would say if you have log e g of x, the derivative with respect to x is g dash x over g of x. Therefore, your f dash of x, which is the derivative of the whole thing, will be sine x at the bottom. What is the derivative of sine x? Cos x, okay? So I used chain rule implicitly. And f dash of pi on 3 will be cosine pi on 3 divided by sine pi on 3, which is half divided by root 3 on 2, which gives you 1 over root 3 or root 3 on 3. Okay? That's it. Very easy. Question 2, 5 marks. Find the antiderivative of cosine 1 minus x with respect to x. So, recall that cosine ax plus b dx gives you the antiderivative 1 on a sine ax plus b plus another constant c. Therefore, your antiderivative of cosine 1 minus x dx will be sine 1 minus x. But be careful, the coefficient of x term is minus 1. Therefore, you need to divide minus 1 in the beginning, plus c. So, an antiderivative where c equals 0, an antiderivative is minus sine 1 minus x. Okay? Evaluate the definite integral from 1 to 2, 3x squared plus 4 on x squared. So let's rewrite this expression in negative index form. And your antiderivative, which is denoted by a square bracket, to be evaluated from 1 to 2. 3x squared gives you x to the power of 3. And plus 4x to the power of minus 1, because you are actually raising the power and divided by minus 1. So this will be x to the power of 3 minus 4 on x, 1 to 2. And set the definite integral up like that. 2 bracket with a minus in the middle. 8 minus 4 on 2. You substitute x equals 2. Then 1 minus 4 on 1, which is 6 minus 2 minus 1 minus 4. All right, that's your 6 minus 3, which will be 9. Okay? Find f of x given that f4 equals 25 and f dash of x equals 3x squared on 8 minus 10x to the power of minus half plus 1 for x greater than 0. So this is your derivative function. We are looking for its antiderivative satisfying the boundary condition, which means x equals 4, y equals 25. But your answer should be written in terms of f rather than y, okay? Let's do f of x is an integral 3x squared over 8 minus 10x minus half plus 1. And don't forget your dx. What should we do next? Then you just compute the integral x to the power of 3 on 8. Okay? Like, for example, 3x squared dx gives you x to the power of 3 plus c. And the next term is minus 10x minus half plus 1, which is half, divided by half, plus x plus c. Therefore, your f of x will be x to the power of 3 divided by 8 minus 20 square root of x plus c. Now, you want to find the value of c. So, f of 4 equals 25. Therefore, 4 to the power of 3 divided by 8, which is here, minus 20 root 4 plus 4 plus c equals 25. It turns to the simple arithmetics you learned in like year 8 or year 9. 4 to the power of 3 is 64 divided by 8. Minus 20 times 2, 40, plus 4 plus c equals 25. Let's keep calculating. Thank you, black pen. 8 minus 40 plus 4 plus c equals 25. And 12 minus 40 is minus 28 plus c equals 25. Therefore, c is 25 plus 28, which is 53. And don't forget to restate the rule of f of x, because that's the question, that's what the question is looking for. X to the power of 3 on 8 minus 20 root x plus 53. Okay? That's it. That's your final answer. Okay, moving on. Question 3 is 3 marks. State the smallest positive value of k such that x equals that is a solution to that equation. So let's substitute that x value, sub x equals 3 pi on 4. You should get tangent 3 pi on 4 equals cosine 3 pi on 4 times k. Okay? Now, what is tangent 3 pi on 4? Where is that? It's here. It's a quarter pi less, going backwards. So it's minus 1, plus 1, sorry, root 2. And your cosine 3 pi times k on 4 equals minus 1. Let's think about cosine what equals minus 1. Let's do a simple diagram. Okay, that's half pi, that's pi, that's 3 pi on 2, and 2 pi. There we go, 1 minus 1. I think the smallest positive value for the inner bracket to be cosine bracket minus 1. So 3 pi k over 4 equals pi. I am actually equating that to pi. Therefore, your k value should be 4 on 3, okay? You just need to do something like pi over 3 pi on 4. Cancel, cancel, 1 on 3 on 4, which is 4 on 3. Flip that around. Solving a hidden quadratic equation. So let u equals sine of x. 2u squared plus 3u minus 2 equals 0. And 2u, let's say 2 is here, minus 1 is here. Cross multiplying, you have 2u minus 1, u plus 2 equals 0. Therefore, u equals half and u equals minus 2. In that case, we are talking about sine x because we want to put it back. Sine x equals half or sine x equals minus 2. But we both know this is impossible because sine x has a range of minus 1 to 1, no solution. How about the first case? Sine x equals half. Let's do a simple diagram. Here and here, okay? This is pi on 6. This is pi minus pi on 6, which means your only x values could be pi on 6 or 5 pi on 6, okay? These two are the only solutions. All right. Copy, paste. Therefore, x equals that and that only. Okay, don't forget your domain. Moving on. This is a sketching question. Let f be a function restricted from minus pi on 2 to pi on 2. F of x is tangent to x plus 1. Plus 1 is a translation upwards by 1 unit. How about a 2 here? So let's think of 2x smaller than minus half pi to half pi. Then it will go from minus pi on 4 to pi on 4 because you are dividing 2 for each term in this inequality. Now, with these two values, it is very convenient for us to directly draw two what? Asymptotes. There we go. Okay, now let's use my rubber. Actually, in Australia, we shouldn't say this term rubber. It's a more like an American or Canadian term. We should say eraser, okay? If you say rubber, it will cause some misunderstanding, okay? Fancy language. if we make x equals 0, f of 0 will definitely be, let's say 0 plus 1. Okay, 0, 1. That's your y-intercept. And if f of x equals 0, tangent 2x plus 1 equals 0, and tangent 2x equals minus 1. Therefore, 2x equals minus pi on 4, and x equals minus pi on 8. So, in between these two markers, in the middle, okay? Let's label it with its coordinates. Minus pi on 4, 0. We know the graph of tangent looks like that. It has some sort of rotational symmetry. So I will mark in a point here and draw the shape nicely. Okay, what else? And don't forget our domain restriction, minus pi on 2, pi on 2. So I would say, okay, what is the period? Period equals pi on 2 times half, which is pi on 4. If I choose this point, and I can translate this point by one period away from that point. So that means from here to here to here to here to here. My next point, next x-intercept will be here, okay? Let's mark in the point here. Similarly, we have 0, 1 to be, no, not half pi, sorry. Let me explain that again. So it's pi on n for tangent function, n equals 2, so period equals half pi. I am moving that point from here to here by half pi. That's one period, okay? Similarly, this distance will also be its period. Half pi, 1. And I need to join these 2 points up. Your graph should not go over this point because the right end point is half pi. And I can also duplicate this bit to here, okay? And this point is essentially a left end point. Minus half pi 1. A small detail. This point and this point. Distance between these 2 points should be half pi as well, okay? That's the specialty of periodic functions. Am I finished? Label any asymptotes with the appropriate equation. Yes, x equals minus pi on 4. X equals pi on 4. Asymptotes. And do we have the endpoints? Yes, endpoints. I missed another point. That's minus pi on 8. That's 3 pi on 8, 0. Okay, so we finished. Use features of the graph in part A to find the average value of f between x equals minus pi on 8 and x equals pi on 8. So I will use the handy feature of my software and do a very simple copy-paste. Screenshot, copy, yes. This is much easier for us to refer to. In your actual exam, you could do a rough sketch by duplicating the graph you already drawn on another page. So the average value, I would say it's the mean value, isn't it? Where is the mean value of the function? Let's look at the center line. Where is the center of that graph? 0, 1. So I'm referring to what? I'm referring to the equilibrium position here, All right, so the average value is 1. Alternatively, you could do things like average value equals 1 over pi on 8 minus pi on 8, integral from minus pi on 8 to pi on 8, tangent to x plus 1 dx, which will be a long, painful, tedious process. Normally in math method, they won't expect you to directly compute the antiderivative of tangent to x unless you are a specialist math student. Excuse me. But if you really want to do that way, let's do some simple calculation first. You could argue, okay, this first coefficient is 4 on pi, from minus pi on 8 to pi on 8, tangent to x dx, plus 4 on pi integral minus pi on 8, and 1 dx. You should notice this one is an odd function. For any odd function f of x, the integral from negative a to a equals 0. So this term will directly cancel out. And finally, you will need to evaluate this term, which is not very hard at all. This will give you, for example, 4 on pi x minus pi on 8. Pi on 8. So it's pi on 8 plus pi on 8. And they cancel down to what? 1. Okay? As we calculate, as we expected here. All right? Average value. There is another method. Let me show you. We know average value is the area divided by width. What is the width? The interval length. So what is our area? This is our area, isn't it? And if you mark in this area by using your highlighter, and you could observe a nice symmetry here. So you only need to calculate the rectangle. Once you get the area of the rectangle, you just need to, okay, 2 times pi on 8. That's pi on 4. Pi on 4 divided by pi on 4. 1, okay? That's the third method to compute the average value of the function between minus pi on 8 and pi on 8. All right, that's enough. Let's move on to see what's the next question. Question 5. Records of the arrival times of train at a busy station have been kept for a long period. The random variable x represents the number of minutes after the scheduled time. Okay, minutes after the scheduled time. So if it's a -1, that means, okay, 1 minute before the scheduled time. Exactly on time. 1 minute delayed. 2 minutes delayed. Okay? That's how I would interpret this question. Assume that the lateness of the train arriving at this station is independent of the lateness of any other train. Looks like it's something to do with binomial. Normally, if I see this term, independent, I will encounter many probability questions involving binomial distribution. That's just my experience and guessing. Let's see. So first part, we want to find the value of P. Don't forget, if you sum up all probabilities in a probability table or probability distribution, you will end up with 1. Therefore, 0.8 plus P equals 1, and P equals 0.2, okay? So let's find E of x, the expected value. The expected value is summing up the products between x and each probability. We have -1 times 0.1 plus 0 times 0.4 plus 1 times 0.3 plus 2 times 0.2. Okay, so we have -0.1 plus 0 plus 0.3 plus 0.4, which means you are getting a value of 0.6 if I'm not mistaken. Find variable of x. So variable of x has a nice little handy formula. Expected value of x squared minus expected value of x itself squared. Okay? I want to get the value of ex squared first. So ex squared means we are summing up all x squared with its probability. And you should have -1 squared times 0.1 plus 0 squared times 0.4 plus 1 squared times 0.3 plus 2 squared times 0.2, which means your first term is 0.1, second term is 0, third term is 0.3, fourth term, okay, you should have 2 squared, 4 times 0.2, 0.8. Now you have 1.2, which is 6 on 5. What's next? 0.6 is your EX. That is 3 on 5. And your variance will be 6 on 5 minus 3 on 5 squared, which means 6 on 5 minus 9 on 25. Okay, common denominator, 30 minus 9, which is 21 on 25. If I'm not mistaken, that's the answer. All right. A passenger catches a train at the station on 5 separate occasions. An indication of using binomial distribution, but what is our value of P? What is the probability that the train arrives before the scheduled time? Okay, before the scheduled time we only have -1 corresponding to the probability 0.1. So my probability is 0.1, which is 1/10. Okay, I want x value equals 4. Let's recall the binomial distribution. If x is a binomial distribution with n and p, then its probability function is ncx times p to the power of x times 1 minus p n minus x. In that case, probability x equals 4 is given by 5 choose 4, 1/10 to the power of 4. Then the rest will be 9/10 to the power of 1. And what's next? We know 5C4 is 5 factorial, 4 factorial, 1 factorial, which means 5 times 4 factorial divided by 4 factorial. Okay, that's 5. Just 5. And the next term is 1 over how many zeros? 4 zeros. I'm correct. 9 over 10. Cancel them down. You have 2 here. So the probability should be 9 over 2, 0, 0, 0, 0. That's it. That is your probability of catching up exactly 4 of these occasions. where these trains arrive before the scheduled time. Okay? Not very hard at all, as long as you know how to formulate the probabilities. All right, moving on. At a large sporting arena, there are a number of food outlets, including a cafe. The cafe employs 5 men and 4 women. Okay, five men, 4 women. 4 of these people are rostered at random to work each day. Let P represent the sample proportion of men rostered to work on a particular day. So, out of these 4 people, N equals 4. Let's say X is my number of male staff who are rostered in this occasion. So X could be none of these are male staff, or just 1 male, 2 males, 3 males, 4 males, 4 out of 4. So your P hat will be X divided by N. So your P hat will be 0, 1/4, 2/4, which is half, 3/4, 4 out of 4, which is 1. Now, for P hat equals 0, that means your X value equals 0. But can we use binomial distribution? No. The trickiest part of this question is understanding the term rostered. For example, if you have 9 people at the very start, let's use this diagram. You rostered 1 person, the first one, you have 9 people. The second one, you only have 8 people to be rostered. The third one, 7. The fourth one, 6. 9, 8, 7, 6. 1 less each time. Therefore, this is not a binomial distribution. In fact, it's hypergeometric distribution. So for X equals 0, that means no men, but 4 women. For no men, I'm choosing 0 out of 5. For 4 women, I'm choosing 4 out of 4. Total case will be 9 people choosing 4. Using some knowledge from year 11, I will be confidently calculating this probability. So it's 5C0 times 4C4 divided by 9C4, isn't it? All right, now it's our job to calculate the value of 9C4. What is 9C4? 9 factorial, 4 factorial, 5 factorial. So it's 9 times 8 times 7 times 6 divided by 4 factorial at the back. 5 times 4 times 3 times 2 times 1. Okay, these two will get rid of each other. And 8 get rid of 4 and 2. 3, okay, 3 and 6, 2. So it will be 9 times 7 times 2 divided by 5. What else? 9 times 7. What is 9 times 7? 9 times 7 is 63 times 2, 5. Okay, so 1 times 1, 126 on 5, which is 5 on 126. Did I get the right answer? Let me have a quick check. Yes, 5 5 male, nothing, times 4 out of 4 female divided by 9 choose 4. Must be something. Ah, right. I see where I went wrong. Let me have a look. It's actually 4 factorial times 5 factorial, 9 times 8 times 7 times 6 times 5 times 4 factorial. And these two, you get rid of each other. Then it's 9 times 8 times 7 times 6 times 5. 1 times 2 times 3 times 4 times 5. These 5 will get rid of each other. 2 and 3 get rid of 6. That's 2. So 18 times 7, 6, 5, 126. Therefore, I should have 126 at the bottom. So your probability will be 1 on 126. Okay? All right. There are over 80,000 spectators at a sporting match at the arena. 5 in 9 of these spectators supports Goanna's team. A simple random sample of 2,000 spectators is selected. Okay, so sample size is 2,000. My probability of success, who supports the Goanna's team, 5 in 9. My standard deviation of p hat will be root p times 1 minus p divided by n, which is 5 on 9 times 4 on 9 divided by 2,000. Okay, what's next? This will be 20 divided by 81 times square root of 1 on 2,000. Cancel them down, you have 100 here. So you end up with 1 on 81 times 100, which is 1 on 81 times 1 on 100. And this is 1/9 times 1 on 10. 190 is your final answer. Okay? Probably you want to have a quick look at your own solutions. Then we move on to the next question, okay? All right. Question 7. Function f is a cubic, function g is a linear. So g of f of x equals 4 minus 2, 2x to the power of 3 plus 1, which is 4 minus 4x cubed minus 2. Okay, g of f of x equals 2 minus 4x cubed. Find f of g and express it in the form k minus m times x minus d to the power of 3. mk are integers, mkd are integers. Okay, so f of gx equals 2g of x cubed plus 1, which is 4 minus 2x to the power of 3 plus 1. But it's not in the form we want to express given in the question. So let's write it as 2 minus 2 bracket x minus 2 cubed plus 1. Then you have 2 minus 2 cubed x minus 2 cubed plus 1. 2 times minus 8 x minus 2 cubed plus 1, which is 1 minus 16x minus 2 cubed. Therefore, your f of g x is 1 minus 16x minus 2 cubed. Okay? The transformation T maps the graph of y equals g of x, g of f of x onto the graph of y equals f of gx. Okay, so we want to transform that function in the form of f of gx, the first one into the second one. Let's drop down from y equals 2 minus 4x cubed to y equals 1 minus 16x minus 2 cubed. I think this value a here, it's a dilation of a from x. Translation is b and c, okay? So if I spot the leading coefficient here, minus 4 and minus 16, I would guess, okay, if it's a dilation factor of 4 from x-axis, then it becomes 4 times 2 minus 4x cubed, which is 8 minus 16x cubed. But we still have some differences. 1 and 8, x minus 2 and x. So let's try translation. 7 units down. So it's 8 minus 16x cubed minus 7, which will be 1 minus 16x to the power of 3. And let's try translation 2 to the right. So 1 minus 16x minus 2 cubed from here to here. Therefore, A will be 4, definitely. B will be 2, because we are shifting the graph to the right. And C value should be minus 7, okay? Nice transformation question. Let's move on and continues over page. As I talked about, if you see that indication, it's a warning sign. The big boss is behind. The rule for a function f is given by f of x equals root 2x plus 3 minus 1, where f is defined on its maximal domain. Find the domain and the rule of the inverse function f inverse. So let y equals f of x inverse swap x and y. So x equals root 2y plus 3 minus 1. X plus 1 equals root 2y plus 3. X plus 1 squared equals 2y plus 3. And 2y equals x plus 1 squared minus 3, and y equals half x plus 1 squared minus 3 on 2. Therefore, the rule of f inverse of x is half x plus 1 squared minus 3 on 2. But how about its domain? So we need to think of the original function and look for the range of f. What does that graph look like? That graph should look like something like, okay, negative 1, that's minus 1, that's minus 2. So I can write it as 2x plus 3 on 2. It's like a translation of 3 on 2 units to the left in the middle here. So the graph will roughly look like that, okay? Let me do a rough sketch. Okay, So we are going from -1 to infinity. Range of f is the domain of f inverse, which is -1 to infinity. Therefore, in full functional notation, f inverse is going from -1 to infinity, restricted f inverse will be half x plus 1 squared minus 3 on 2, okay? Rule and domain. Solve f of x equals f inverse of x. If you have something like y equals f of x and y equals f inverse of x, at least one point of intersection will appear on y equals x. So this time I'm choosing, let's say, f of x and y equals x, and solve them simultaneously to get its point of intersection. Actually, what I have drawn here in this rough sketch will also help you to determine how many points of intersections they have. Look at the blue graph. The blue graph is our f of x. If I take the inverse, the point will be -1 minus 3 on 2, okay? So it roughly looks like that, okay? This is my f inverse of x. I will have one point of intersection. And this is y equals x. So we solve for x equals root 2x plus 3 minus 1. So x plus 1 equals root 2x plus 3. And x plus 1 squared equals 2x plus 3. And x squared plus 2x plus 1 equals 2x plus 3. These two will get rid of each other, and x squared plus 1 equals 3. Now, x squared equals 2. X will be plus or minus root 2. However, guys, be very careful. If you look at your rough sketch here, you know there is only one point of intersection, which is in the first quadrant. So, for f and f inverse to intersect each other, x must be greater than or equal to -1, and you can observe that from its domain. The common domain is here. So x equals root 2 only, okay? It's very important. If you keep both solutions, you are not correct, and you will hence lose mark. All right. Now we have a new function, so we are swapping the one with c. D is the maximal domain of G, and C is a real number. For what values of C does Gx equals G inverse x have no real solutions? All right, so let's try x equals root 2x plus c minus 1. Using the same idea, x plus 1 equals root 2x plus c. X plus 1 squared equals 2x plus c. And x squared plus 2x plus 1 equals 2x plus c. X squared plus 1 equals c, and x squared equals c minus 1. So for that equation to have no real solution, I would say, okay, x squared is greater than or equal to 0. But for no real solution, x squared should be smaller than 0. Therefore, c minus 1 smaller than 0, and c should be smaller than 1. Okay? or you can write it as C is an element of negative infinity to 1. For what values of C does Gx equals G inverse x have exactly one real solution? Continuing from the previous part, we could directly say, okay, when x squared equals C minus 1 equals 0, then C minus 1 equals 0 for one point of intersection. So C equals 1 definitely. However, if you look at your beginning, let's say part B, for C equals 3, they have one solution only as well. So you do need to think of, for example, let's think about an extreme case. An extreme case will be, okay, for a certain value of C, the graph will have 2 points of intersections, okay? I'm doing just a rough sketch, but for some certain situations, they will just be intersecting twice. The first intersection is their starting points. The second intersection will be away from its starting point. So I want to figure out where is this extreme case happening, and we do some comparison. For g of x, we want 2x plus c greater than or equal to 0, isn't it? So x is greater than or equal to minus c on 2. And let's write it in interval notation. For g inverse of x, the range of g equals the domain of g inverse. Therefore, you look at the first equation, -1 is the smallest value. So this time, your domain is -1 to infinity. For that situation to happen, they should have a common domain. That means this one equates to that one. So minus c on 2 equals -1, and therefore c equals what? C equals 2. But c equals 2 is not the answer we want. It's just an extreme value for g and g inverse to have two solutions, okay? Let's compare this extreme value with the previous example. So when c equals 3, they have how many solutions? They have one solution only. Considering part A and B, when c equals 3, which is greater than 2, there is only one solution. So we can guess c greater than 2 for one point of intersection. Now it's time for us to combine this answer and this domain. Therefore, for c is an element of 2 to infinity union 1. There is only one solution to gx equals g inverse of x. Okay? That's my complete answer. All right. I think except for the very last question, which is question 8, which is very tricky in some way, the rest of this paper, they are doable. So hopefully you guys can find this video helpful in some ways, and In future, I will complete the series for the suggested solution in math method. And thank you for watching. See you next time. Bye-bye.